Hello there. I'm going to practice some equations of circles problems. Here's a typical setup where I'm told what the center of the circle is and a point that it goes through. And I'm going to try to get the equation of that in our standard form. So I start by plotting those 2 points, and the first question is going to be, given that this is the center here, how far away are these 2 points from one another? In other words, what's the radius of that circle? So I frame it. There's my right triangle, and now I can apply the distance formula in order to solve for what the radius is. Of course, all of this can be sped up quite a bit if I simply count that that's over 4, and this is down 7. So doing 16 plus 49, I get that the radius here is the square root of 65. And to get an idea of where that circle is, so the circle is this sweeping around here, centered at this point, and it's this uniform distance of root 65, so just a little bit bigger than 8. And I'm going to try to draw it, and I'm going to cheat a little bit when I draw it. I know that this point is down 7 over 4. There's going to be another point over here that's down 7 forward 4, so I'm going to plot that. I also know that there's going to be a point that's down 4 forward 7. Just doing this so that my picture doesn't look totally awful when I'm done. There's going to be another one that's down 4 backwards 7. And then I can get the ones that are up 7, forward 4, backwards 4, and up 4, forward 7, backwards 7. Okay, now comes the challenging part. I'm going to try to do my best to draw a circle that hits all of those points and doesn't look totally terrible. Good enough for government work. Okay, so there's my circle. Now I'm going to try to figure out the equation of this thing. I'm going to imagine an arbitrary point somewhere out on the circle called xy. Actually, I should point out at this point that as soon as I have the center of the circle and the radius of the circle, I can actually jump to the equation of the circle if I'm very familiar with things. So if you're comfortable with the equation of a circle, you can just jump right to it. What I'm going to do now, however, is talk about how we can derive the equation of a circle, imagining an arbitrary point that is this set distance from a center here. So I'm going to frame it with a right triangle again. Now I know that this length here, no matter where this point xy is, as long as it's on the circle, this point here is root 65 away from the center. Then I try to break down what is this horizontal displacement here. Well, it's going to be the difference of the x's there, so it's going to be x minus this x. And this vertical displacement is going to be y minus this y. Once again, the distance formula is just the Pythagorean theorem here, so I have this component, this leg, I'm going to do this quantity squared plus this vertical one, quantity squared. This minus a negative I'm going to clean up. And this portion over here, root 65 quantity squared, I can just write that as plain old 65. And there we go, that's the equation of my circle in standard form. I do not expand this, I don't turn it into x squared minus 2x plus 1, y squared plus 4y plus 4. I leave it like this because looking at this, I can quickly see that the x coordinate is at positive 1, and the y coordinate over here is at negative 2. So this form, and radius root 65, got to remember to take the square root. So this form of writing it, I can just glance at it and quickly see what my center is and what the radius is. Character and scholarship for life.